Thank you for joining me on this question. I'm going to look at question 16. And question 16 says solve 2p squared minus p minus 1 equals 0. Well, I'm going to try and solve this using factorising. And first of all, will it factorise? Now, it will factorise if our discriminant b squared minus 4ac, that's the part under the square root sign, is a perfect square. If it's a perfect square, such as 1, 2 2s are 4, 3 3s are 9, those sort of numbers, then it will factorise. A is 2, the coefficient of p squared, b is negative 1, c is negative 1. So let's do this. B squared, negative 1 squared, minus 4 times a times c. So 1 minus 4 2s are 8, that's a negative 8. That makes 1 plus 8 equals 9. Yes, it will factorise because that's a perfect square. So let's find two numbers that multiply to give AC and add to give B. All right. Now AC is negative 2. 2 times negative 1, and b is negative 1. All right, so let's do this. 1 times negative 2, and there's our answer. 1 plus negative 2. The two numbers are 1 and negative 2. 1 and negative 2. All right, so let's take this 2p. I like to put 2p over 2, and then put the two numbers which got plus 1 and a negative 2 in those brackets. That 2 will cancel with the second bracket because there's 2 common, and the first bracket doesn't get changed, so that's 2p plus 1. Now we've cancelled the 2, so that's p minus 1. Therefore p equals 2p. We write, I'll do this a little bit slower. Therefore, that bracket has to equal 0, or that bracket has to equal 0, because there's a factor, there's a second factor, and one of those factors has to be a 0, so that when you multiply them, you get a 0. So either the first factor, we'll take the plus 1 across to be negative 1. Take that times 2 across to be half. And take the minus 1 across to be 1. Right, so there's our answer for part A. Part A means p is equal to negative a half, or p could equal 1. Part B. Well, this is very interesting because part B, it's got almost identical, the same quadratic, but this time it says instead of p squared, instead of 2p squared, it's 2 cos x squared, and that's the same as cos squared x, minus, and instead of p, we've got minus cos x, and we've still got a minus 1 equals 0. Now we were told that x is somewhere between negative pi and pi. So this means there's negative pi is that way, and positive pi is that way. So we're still dealing with all four quadrants, and we're dealing with that theta, the first quadrant. Pi minus theta is the second quadrant. And when we come backwards, that's negative theta, and this is negative pi plus theta. So negative pi plus theta takes us into the third quadrant. So therefore P is like cos x. So if we let cos x equals P, then 2p squared minus p minus 1 equals 0. Therefore, just like what we've just done, therefore p can equal negative a half. We don't have to solve it again. Or P equals 1. So we get these two possibilities. Remember, P is cos x. So put cos x equals negative a half. Or cos x equals 1. Well, let's look at the negative a half first. And you would have learnt ASTC. These are the quadrants where they're positive. They're all positive in quadrant 1. Only the sine is positive in quadrant 2. Only the tan is positive in quadrant 3. Only cos is positive in quadrant 4. So which quadrants is cos negative? Which quadrants is cos negative? Because it's a negative a half. We're dealing with this quadrant over here, and we're dealing with this quadrant here, because cos is positive in quadrant 1, cos is positive in quadrant 4, which means we're dealing with pi minus theta, and we're dealing with negative pi plus theta. That's the two quadrants that I mentioned before, pi minus theta and negative pi plus theta. Well, I like to just say, well, if cos of x, just consider the positive part. If cos of x is a half, right? This is just ignore the negative and consider theta being a first quadrant angle. So really we want to find this theta value here. If I can find theta, I can substitute it into our two rules here. Well, if cos of theta is a half, maybe you remember, therefore, sine of 30, sine of 6, pi and 6 is a half, or cos of the reciprocal, cos of 60 is also a half. And it's this one here, cos of 60 degrees, or cos of pi over 3 is a half. Therefore, theta is pi over 3. And if it's negative, it's quadrant 2, which is pi minus theta. So it's pi minus pi over 3. So that's 2 pi over 3. And if it's quadrant 4, we established, quadrant 3 in this quadrant here, it is negative pi plus theta, which is negative pi plus pi over 3. So it's negative 3 pi over 3 plus 1 pi over 3, negative 2 pi over 3. Right, that's if cos is negative a half. Well, let's look at cos of is equal to 1. And if you know the unit circle values, where the radius is 1, this is the point 1, 0, this is the point 0, 1, this is the point negative 1, 0, this is the point 0, negative 1, and we're dealing with theta is 0, theta here is pi over 2, theta here is pi, theta here is 3 pi over 2. But if we come back here, this is negative pi over 2, and this is negative pi, all right? And cos is the adjacent side. Cos is the adjacent side, and over 1, the hypotenuse, and sine is the opposite side, which is the y value. So the x value is cos, and the y value is sine. So cos theta is the x value, sine theta is the y value. Where is the cos, where's the x value? -1, and it's over here. Oh, no, that's +1. We want a +1, it's over here, 0 degrees. So here, since cos of 0 equals 1, therefore x is 0. So we've got 3 answers. Our solution set is that x could be 2 pi over 3, x could be -2 pi over 3, and x could be 0. And they are your 3 solutions for part B. Wow, a lot of fun. I hope this has helped. Until next time, stay happy.